Non-radial models. Now, the input-oriented or the output-oriented envelopment models are also called radial models because the inputs are being reduced in the same proportion or radially. If you recall, how you get the projection on the frontier is you connect a DMU with the orange. So this is how you get the projection radially. All these models are called the radial models. Here we're going to introduce a set of models that's called non-radial models. Again, in the very first DEM models that we discussed, the envelopment models, these are called the radial models. The inputs are being reduced in the same proportion and the outputs are being increased in the same proportion. This is again the example that you've seen before. How you measure the efficiency of DMU A is you connect in the origin to the A and you get a front intersection on the frontier B. So both inputs are being reduced in the same proportion radially. What is a non-radial model is that you break down the efficiency into individual factors, one for each input and one for each output. So instead of having one theta, you will have m thetas. Okay. And now you see a version of the CRS model. Instead of having a 1 theta in front of all the x, all the inputs, you have 1 theta for each input, and you're going to minimize the average of the theta. Okay, average of theta. Now I use the equality here. It's because you're not going to get slacks because you reduce each input individually. Okay, so you can always hit the frontier. You can always hit the frontier. And you notice that you add a constraint that all the theta I are less than or equal to 1. You have to add that constraint. So if you're going to build a spreadsheet model in Excel, don't forget to add that constraint. Okay, add that constraint. And this is the output-oriented non-radial model. Okay, so you maximize the average of the each individual output efficiency, and don't forget to add the efficiency is greater than or equal to 1 for all inputs. Once you add the constraint on the sum of lambda j, you get the other type of non-radial models. Usually you will get a different projection point on the frontier. This is an example. So if you look at this DMU5 with 4 and 3 being the 2 inputs, and assume of course the outputs are the same across all the DMUs. This box on the frontier is the target from the input-oriented model. And if you apply the non-radial model, you get a target on DMU2, so you get a different target. If you use a different, use the non-radial model, but sometimes you can get the same target. And this is the model for calculating the efficiency and for the DMU5 that you just see in the picture.